Hello everyone and welcome to this another episode of 3D prototyping in Unity. My name is Kasanas, and the last episode we took a look at setting up our basic character and our basic environment. This character is ready now to have scripts applied to allow us to be able to interact and move about. Alright, so in today's episode we're going to be writing those scripts and getting our character to run about. Let's get started. Okay, so there's not a whole lot of work we need to do to get this character running about. Now, what I have done already is I've added in a couple of floors here to be able to have my character run around the floors. You guys don't have to do that if you don't want to, but that's what I'm going to be doing. Okay? Just going to allow me to run around here. Ultimately, I'm going to delete these anyway and build myself a proper environment, but just for test purposes, I've added these in. Okay, so there's a couple of things that we really want to do in order to be able to have this character running properly. The first thing I want to do, let's go to our player. I'm clicking on the player, and I'm going to go to my animator settings. Now, sorry, my animator tab. Now, my animator tab currently has, I still haven't fixed that. My animator tab currently only has my idle left in location. Now, what I want to do is I want to add in one more animation, and I'm going to go to do that. I'm going to go to my models. I'm going to click on models. Bam. I'm going to find my run animation right here. So in the game that I've got here, the game that I created here, my character either ran, they didn't walk, they were either idle or they ran. Alright, so I'm just going to add those two animation states in there. I'm going to right click on idle left, and I'm going to say make transition, and I'm going to have it go across to run, and I'm going to click on run, right click, make transition, and have it go across to idle left. These two states and these transitions between will allow me to go from idle to run, and in some condition occurs back to idle. Alright, this is basically a state machine or an animation map. You can call it whatever you'd like, but it allows me to transition between various states of animation that I already have prearranged. So, with these two states in place, I need a reason or a parameter that's going to allow me, some kind of condition that's going to allow me to switch between these two states. Okay, currently my list of conditions to switch is empty, and it is working on an exit time. I don't want that. I want to turn off exit time immediately. So right now there's no reason at all why these will ever switch. I'm going to apologize right now. I know I probably sound really funny. Illness has, overwhelmed my house. Everybody in my house is sick, but I still got to get these out, so I'm still making these videos even though I sound terrible. Anyway, so right now we've got ourselves no conditions at all, no reason why we'd ever go from idle to run. I want to do exactly the same thing with the run to idle. I don't want to leave after a certain amount of time. That's what has exit time means. It means once I'm in here, after a certain amount of time, transition back. And I don't want that. All right, I don't want that. What I do want to do is take each one of these, I want to scrunch them down like this, and I want to move them to the front. Alright, just like that. And on the same thing on this other transition, so all I'm doing is clicking on the little arrows. I'm going to scrunch it down, and I'm going to drag it to the front. So basically, this is allowing transition times between the different states. And by scrunching this time down, I'm having a very, very quick transition. So there's not a lot of blending that's going to occur. My character is going to immediately move from the idle state into the run state, or from the run state into the idle state. Depending on the type of animation that you've created, you might want to adjust that. You might want to have longer states or longer transitions that allow more blending to occur. That's going to be up to you guys to decide depending on the animation that you're using and the type of game that you're creating. For this, like I said, I scrunched them down, moved them close to the front so the switch can occur very quickly right away. Alright, we need a reason why we're going to transition from the idle to the run. So I'm going to go over here into my animator tab still. You have a choice of either layers or parameters. I want you to click on the parameters, and I want you to add a brand new Boolean. Alright, now brand new Boolean. You have a number of different options there. You have Boolean, you have trigger, you have float, and you have int. In our case, we're either going to be running or not running. Okay, so I'm going to use the Boolean, and that's a true or a false. And it will remain true until it's set to false, and it will remain false until you set it true. That's what a Boolean does. And I'm going to call this Boolean is running. And the default state is going to be false, so this is perfectly fine. Now, over here, back in our transitions, if I click on the little arrow, and I take a look down here, my list of conditions is still empty, but if I hit the plus sign now, it's going to automatically offer me any of the parameters that I have set. In our case, is running as a parameter, and whenever it's true, we want to move to running. So basically, whenever I set the value to true, we're going to move from the idle into the running state. And Conversely, if I'm running, I'm going to hit the plus sign here again. If I am running and suddenly I want to be idling, I'm not running anymore, whenever our is running is false, I want to move back into the idle state. Okay, so this simplistic animation state has various conditions that will allow me to move back and forth between these states. And this is set up just as I want it to be now. All right, now we have to create the code that's going to allow us to actually transition between these two states. Okay, so to get this character running, let's go over to our player. Let's click on player. And currently we've got a number of different nodes available to us in here. What we want to do is we want to add component. We want to go down to new script, and we're going to create a brand new script. Let's call this player movement. All right, now I'm going to hit return. And when I do so, we will get a brand new script that appears right down here at the bottom of our player. The only parameter currently available in that script is the actual name of the script, player movement. I'm going to double click on it, and it's going to take a second to launch, but we're going to launch mono develop, and we're going to launch it on a different screen. So let's bring this over. All right, there's mono develop. Let's zoom in here a few times. View, zoom in, view, zoom in, view, zoom in, view, zoom in. And let's do one more just to make sure everybody out there can see. View, zoom in. All right, so here's our player movement class. The script has already been added to our player. We have to go through now and add in the appropriate lines to make sure that we're going to get our character to be running about. Let's just say yes, use Windows. All right, so there are a number of things that we have to add. The first thing I'm going to add, I'm going to go right below this player movement. And what I'm going to add is a variable. I'm going to add a serialized serialized field, excuse me. And the serialized field, I'm going to call, it's going to be a float that I'm going to call, let's call it run speed. And we're going to set it to a default value of 10F. So it's a float. You have to add in the 10F. You have to add in the F to make sure that it knows it's a float. Otherwise, it's going to give you an error. Anyway, so the 10F is just a guess. If it's not the right speed, this is a serialized field, which means it will appear in the over here. It will appear over here in the inspector, right over here in the inspector. Later on, when we save this, we'll actually see the field down here in the inspector and be able to make adjustments at runtime. And that's awesome because that allows us to go through and adjust these things at runtime, decide what the appropriate numbers are, and then go through afterwards and plug them back in. All right, so for now, 10F is our guess. Okay, we're going to need a couple of other things too. We're going to need a vector 3, that we're going to call movement. And this vector 3 is going to be used to retain the vector, our movement vector. Okay, that's exactly what it's for. We're going to build that later on in the script. We're going to need a couple of other things here. We're going to need a float value that we'll call H, I guess is fine. H is going to be the value of the input from our horizontal axes, and we'll discuss horizontal axes in a little bit when we get to that code. All right. I also need a float value that we will call V for vertical, and that is going to be our input from our vertical axes. All right, our player input from our vertical axes. Both of these values, H and V, are going to be used to make up our movement vector. Okay. A couple of other things that we're going to need in here. We want a link to our animator. We want a reference to our animator. And that animator is going to allow, having a link to our animator is going to allow us to switch back and forth between our different states, allow us to send information to our animator's parameters and then shift states. So let's call this my AC or player AC. You can call it whatever you want. Player anim, maybe I'll call it. My anim. I'll call it my anim. All right, so that's our reference to our animator. And we also want a reference to our rigid body. And I will call it myRB. And the link to the rigid body is going to allow us to, this reference to the rigid body is going to allow us to go through and adjust forces on our rigid body, apply force to a rigid body, or change its velocity, or change its positioning, a lot of different things. So a lot of different ways to actually do movement using a rigid body. And in fact, in this series, we're going to go through and we're going to make some adjustments to how we do it. Normally, I go through, depending on how you want this to your character to behave, you can use velocity to adjust the rigid body's velocity automatically, and adjusting the velocity allows for very, very arcadey style movement, but it's not always accurate, and it affects physics a little bit. So in this series, we're actually going to take a different view, a different approach to character movement. Okay, so I think that is all we're going to need as far as initial variables are concerned. We're going to go in here and we can either use our start or our awake function. The awake is called before the start, so it's up to you which one you're going to use. Sometimes the order will matter. In this case here, I don't really think it does, but we'll go through and we'll use our awake function anyway. There's a couple of things we want to do in here. In our awake function, we want to set up the references to our animator and our rigid body. And to do so is very, very simple. We're going to say myAnim is going to be equal to getComponent, and I'm using getComponent because the component is actually located on the same layer as the script is. The script is on the top layer of my character, and my rigid body and my animator component are both on that same layer. If it was on a different layer, you'd have to use a different get, either get component in parent, get component in children, etc., etc. All right, in our case, it's on the same layer, so we can use our get component. All right, and get component, I'm looking for an animator, boom, and the syntax is as such. All right, and that's going to give us our reference to the animator itself. Now, if you really were worried about it, you could go in and put some error checking in here to make sure you actually had an animator. I'm not going to worry about that right now. This is basically a prototype rather than a finished game. There's not really any error checking or optimization that's going to occur within this series. We're going to do exactly the same thing for my RB, which is going to be equal to getComponent, and once again our component is located on the same layer, so we can simply say that we're looking for a rigid body, bam, and boom, ba-doom, boom, boom, and that is our basic syntax right there. Okay, so now that we have everything initialized, we actually want to get into the meat of these scripts. And what we're going to see down here right now, when you start up a brand new class like this, a brand new script like this, you end up with a number of different things. We had a void start to begin with, and we also had a void update. In our case, we are going to be moving the rigid body. We're going to actually be affecting the rigid body directly, and whenever you're making movement that is dependent on physics and you want physics and everything to kind of all be working together appropriately, you really want to work within the fixed update rather than the update. So it's actually not called every frame, it's called at a fixed time. All right, and this basically allows our character and our input to be received at the same time as the physics engine updates are occurring as well. So fixed update. What do we want to do in here? We want to basically figure out each fixed update whether our player is actually pushing a button for input. And as I mentioned before, we're going to be using a horizontal axis and a vertical axis to determine whether the character has pushed any buttons. Now, if you're wondering what axes are, if we go over here, let's go take a look. If we go to Edit, and we go to Project Settings, and we go to Input, over here in the Input Manager, we can now see that there are a number of axes that have been defined for us. And axes are basically button pushes, or buttons, or mouse buttons, or everything like that. Joysticks. All these different things have been predefined for us with these simplistic names, rather than saying get button A, get button D, etc., etc. Simply saying horizontal as an axis will refer to the left and the right arrow keys and the A and the D keys. The left key is a positive value and the left is the negative value and the right key is the positive value. It will give you, if you are simply looking at the axes in general, it will give you a value between 0 and 1 for the right and 0 and 1 for the left. All right, sorry, that's incorrect. 0 and 1 for the right and 0 and -1 for the left. And this will tell the program which button the character is pressing, or the player is pressing, excuse me, and how far down it's been pressed. Okay, that's what the axes allows us to do. And these are all configurable. You can go through and you can configure these in any way that you want to. Okay, so let's go back and take a look at our axes right now. So right now, we don't know if anyone's pressing a button. Right now, there's no indication at all if a button's been pressed. To find out if one has, we're going to set our h value, our float value here, because like I said, it gives you a value anywhere between 0 and -1, basically. Or sorry, -1 and 1. Our h value is going to be equal to, and what we're going to use is we're going to use the input dot get axes raw, or get axes. it's up to you to choose which one you want. Get axes will give you a value. If you're pressing the negative button, it'll give you a value between -1 and 0. Any increment, any real number within -1 and 0. And if you're pressing the positive button, you'll get any real number between 0 and 1. That's what get axes does. Get axes raw will allow you to get a value of either 0 if you're not pressing any buttons at all, or -1 if you are pressing the negative button, or +1 if you're pressing the positive button. That's it, nothing in between. In our case, we don't really care, but we don't really care about a ramp up or how much pressure they put on the button or anything else like that. What we're looking at strictly is whether or not we are pressing the button. So we're going to use the get axis raw. And which axis, this basically takes one argument, which axis are we looking at? In our case, we are looking at the horizontal axes. And you have to get this name right. You have to use the one that was shown in the is it still up? Let's see. Yes, you have to use this one here that's showing right here. It has to be exactly the same. Okay, you can't just put any string in there that you want to. It won't be able to actually find the appropriate axes. Now, H is equal to that. V is going to be equal to our input, exactly the same line. Our input dot get axes raw. And in this case here, we're looking at our vertical. And our vertical values are the up and down key or the W and S key. All right, that's what they're automatically set to. So these two lines here will automatically tell us whether or not our player is pressing the button or not. If not, these values will both be equal to 0. And if the player is pressing either one of these buttons, we'll get a value between -1 and 1 for H. We'll get -1 or 1, and we'll get a value of either -1 or 1 for V. All right, so that's pretty good. Now, what I want to do, rather than doing all of my work within the fixed update function, rather than filling this thing up huge, what I'm going to do is I'm going to create 2 additional functions. I'm going to call this one here move, and it's, I didn't want that. I'm going to call it move. Don't autofill for me. Move, there we go. And, move, that's exactly what I want. Move, escape, and move is going to take a couple of different values. It's going to take a parameter of H and a V. All right, so we're going to be using both H and V in move. It's red right now because we don't actually have move defined, and we'll define it right now. So right below it, bam, bam, right below our fixed update, we're going to set up our void move function. That's going to take 2 parameters, as I mentioned before. It's going to take a float H and a float V. All right, bam and bam. So once I've done this, you can see that my move value right here, there's no longer an error, and move is now appropriately colored. All right, so move is a fairly straightforward script. Basically, we want to set up our movement vector. So we created our movement vector here. We want to set up our movement vector. Our movement vector dot set, we're going to be using the built-in function. Movement vector dot set is going to take an x, a y, and a z value. So whatever our new values are going to be is what it's going to be. All right. We basically want to set our move x to our h value. We want to set our y to 0f, which means this character can't move up and down. So if we had this character moving up and down, we would have to adjust this a little bit. All right. But in this case here, we don't care. If we did, we'd have to go in here and track where the rigid the location of the rigid body, and we'd put the appropriate number in here. In our case, our character is not jumping in any way, so we're going to use our value of 0 float there. All right, and the last one is going to be our V. All right, and that's going to automatically set for us our movement vector. Now, this movement vector is going to be used in a number of different ways. The first thing we want to do with our movement vector is actually determine which way our character is facing. So we're going to use the movement rotation. We're going to use our move rotation for that. So the line of code we're going to use here, I have to sort through this because some of the stuff we're not using right now. Okay, we are using all this. So basically what we want to do is if our H does not equal 0, all right, so if we're actually pushing the H button, and the or is 2 lines like this, or our V value does not equal 0, then we want to actually set the rotation of this character. Okay, oops. We want to actually set the rotation of this character. So we're going to add in some brackets here, our curly brackets. And basically what we want to do is we want to set our rigid body, my RB, and we're going to use the move rotation. And basically what the move rotation does is it rotates the rigid body to be facing in a particular direction. That's what the move rotation does. And we're basically going to use this to determine which direction our character is facing. We want our character to face in the direction that they're running, right? Obviously, if you're running to the left, we want our character to be facing left. If we're running right, up, down, whatever, we want them facing in the proper direction, okay? So we're going to use the move rotation. Now, the move rotation takes in a quaternion rotation. I'm not going to go into what a quaternion is. It's a mathematical description of rotation values. I think most of us here are used to Euler values rather than quaternions, but in our case, we're going to be using our quaternion values, okay? So what we're using here is a quaternion. Quaternion dot look rotation, and the look rotation basically what the look rotation does is it gives a quaternion value. All right, it gives a quaternion value. So let's start this again. Dot look rotation, and we want to convert our movement vector into an appropriate direction. All right, so that's what we're doing. That's our look rotation. We are basically saying, based on our movement vector, turn and face me in the appropriate direction. Okay, and that will do so. Now, the next thing we want to do is we actually want to add movement to this character. So right now we have the input and we actually have the rotation set here, but what we want to do is make sure that the character is moving in the appropriate direction. We're going to use a normalized vector. So first thing we're going to do is we're going to say movement is going to be equal to, and we're going to normalize this vector, movement dot normalized. And the reason why we want to normalize this vector is if you're moving on a diagonal, if you move on a diagonal with this type of input, you'll move faster on a diagonal than you will in either the horizontal or the vertical direction. We want to make sure that doesn't happen. We want to make sure that the character moves in the same amount of the same distance in the same amount of time, regardless of whether they're moving vertically or whether they're moving on a diagonal or they're moving in a up or down, like a horizontal or vertical movement. All right, so we're going to normalize this vector. We're going to multiply it afterwards by the, what did I call it? I called it, I've already forgotten, run speed. We're going to multiply it by run speed to get our actual speed of our character, and we're going to multiply this entire thing times time dot delta time. And time dot delta time basically allows us to divide this up into increments between frames. So all of the movement isn't occurring all at once. All right, so we're normalizing the vector right here, giving us a value of with a magnitude of 1. So we've got a vector with a magnitude of 1. We're multiplying it by the run speed to get the appropriate magnitude, and then we're multiplying it by time dot delta time to make sure that we are the appropriate magnitude over a specified amount of time, which is basically the increment between updates. Okay, so there we go. That's going to give us our appropriate movement. Now, the last thing we want to do, that's our appropriate movement vector. The last thing we want to do is actually apply this movement vector to our character, so our character is going to run in the appropriate direction. So player, no, I didn't call it that. I called it myRB. myRB is going to be equal to, no, I'm lying, myRB dot move position. We're going to be using the move position function, and basically what move position does is moves the rigid body to a particular location over a specified amount of time. If you didn't want to use this, you could use if you just wanted it to teleport automatically, there's other options, but basically the move position allows us to move the rigid body smoothly over a specified amount of time. Okay, so it's basically going to comply with the interpolation settings, which we didn't really discuss for the rigid body. Maybe we'll take a look at that later on, but it'll allow for smooth movement over a period of time. Okay, so we're going to use our move position, and it takes first of all, it asks where we were. So where we were, we're located at transform.position. That's where our character is currently located, and we want to move to movement. That's where we want to move to. Our vector is set up to move the appropriate distance. All right, semicolon, and I'm going to file save this. File save. Now, if I've done everything correctly, let's move this out of the way. If I've done everything correctly, and I click back on our player right here, that's the floor, black on our player right here, we should see, let's scroll down, we should see that we do have our run speed here as a variable, so that allows us to change this value if it's incorrect. And I don't see any errors. Let's take a look at our console. I've got a number of different things. Let's just clear this right now, just warnings. When I hit play, my character should land in into this position, into our idle. And when I hit the buttons, whether I hit the WASD keys or, oh, he's falling over. Let me show you why. I'm actually glad I saw that. We have to go, sorry about that, guys. We actually have to go into our rigid body right here, and we want to make sure we're freezing a number of the different rotations and translations. If your character is falling over, and everyone always asks me about this, and you know what, I always forget to mention it. If you're having this problem, you want to go through and you want to freeze some of your rotations. You actually want to freeze all of them. We want to freeze our X, our Y, and our Z. Okay, and we're not gonna twist based on force. Is basically what this is doing. Okay, sorry about that, guys. Let's hit play again. Play. And when I do so, there's my character. He's not falling over. Everything is good. When I actually hit the buttons, you can see that my character is now moving about. I'm using the arrow keys here. Now, as you can see, my character is not actually animating at this time, but he is facing in the appropriate direction, his direction of motion, and he is moving at an... we'll see if it's an appropriate speed after we get the animation itself in place. Okay, so the last thing we want to do, let's get our editor back up here. The last thing we want to do is actually have our animation working appropriately. So right now we've got our movement working. Awesome. Let's go in here, right in the fixed update, and we're going to add a brand new function. And this function is going to be called, let's call it animate. I'll call it animate. Okay, I can't do that. I'll call it animate. Oh yeah, maybe I can. Animate. Let's call it animate for now. It's going to take a number of, it's going to take the same thing. We're going to take an H and a V value. All right, boom. And we're going to go through and we're going to actually create animate. I wonder if I can call it animate, or is that a protected? I don't know. Let's take a look. Void animate. And it's going to take a float H and a float V. Let's see if I can actually use it. Does it say yes? It says yes. Okay, good. So animate. We're going to call this function animate. And it's going to take a float H and a float V value, exactly the same as our movement did. We could probably have added everything into one function, but dividing it up gives you some options. All right, so we're dividing this up for now. So our animate is going to be very simple. We're going to actually create a bool that I'm going to call running. And running is going to be equal to H as long as H is not equal to 0. And or V does not equal 0. So we're actually setting up the values for our bool right here, okay? And in both cases, I can't just say 0. Actually, I have to put my semicolon here, and I have to put my F there as well. Otherwise, it's going to complain at me later on. So it's going to be equal to the value of whether if H is not equal to 0 or V is not equal to 0, it's going to be equal to that value, okay? So the next thing we're going to do is we're going to actually set our value. Because this is a bool, we're actually going to set our parameter that we had set up in our animator. So if we go back here, let's just take a quick look over here. We have our isRunning parameter, and we basically want to set our isRunning to be true or isRunning to be false. So isRunning will be true if this value is greater than 1, or in this case it's going to be 1 or 0. And it'll cause us to shift between those two animation events. Excuse me, those animation states. Now, basically what we want to do is we want to set our what did I call it? My anim, right? I can't type. My anim, and basically want to set a bool, set bool, and you have to give it a number of different things here. You want to give it the name, the string parameter's name. It's a string, and it's the parameter's name. So we called isRunning is our parameter we want to set, and we want to set it to the value of running. Okay, and that's all we should need to do. So basically we should be setting this parameter each time we come in here. Every time we come through here, we're going to be updating our movement, updating our animation each time. So let me file save that. File save. We didn't add any new parameters or anything like that. Let's actually go into our scene and let's move our camera. Let's move our camera about a bit. Let's get our main camera. let's just move it up a bit so we can see this character a little better. I'm just going to move it like this, and I'm going to rotate it down so we can see our character running about. Okay, so now when I hit play, bam! And my character is currently in the idle state. If I cause him if I push my buttons, you can see I'm automatically moving into the animation run state and out of the animation run state. Now it's happening instantly, and like I said, that is because of the parameters that I've chosen. My character is running and is idling appropriately. If we take a look at it here, I'm going to turn off maximize on play, and I'm going to turn back on my animator state right here so we can see it. We should be able to see it happening right here. If I hit play right now, let's click on our character player. We can see that we are maintaining our idle left. We are staying in our idle left. And if I click over here and I actually click, you can see that my character is moving into the run state and coming out of the run state whenever I let go of the button. Okay? If you are looking for more of a smoother transition for your animation, so you don't want it to instantly transfer from the idle state to the run state, you can change these transition times in here. You can make them bigger, you can make them smaller, you can do whatever you want to get the appropriate look for your game. Okay, guys, that's all I want to do for today. Our character is running about, our character is animating properly. We are ready to actually start taking a look at various things. We're going to take a look at the camera, I think, next episode. Alright, guys, I really hope you enjoyed it. If you did, let me know down below with a thumbs up. A thumbs down is perfectly fine. Please, if you give me a thumbs down, I'd like you to put a comment in there saying, you suck, or, your art's ugly, or whatever you want to say. I don't care what it is, but whatever you're going to say is going to allow me to improve as a YouTuber. It's going to allow me to improve as a teacher as well. I'll know what I'm doing right and what I'm doing wrong. If you think I'm doing something wrong, a thumbs down is great. That gives me the information to help you along. I'm not making these videos for me. I'm making these videos for you. Alright, guys, so thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.